All right, I'm going to talk through some rational exponent problems. I kind of modeled these after the problems that a lot of people got wrong on the exponents quiz, just so that when you work on the next section of the review, these will hopefully help jog your memory on the process that we talked about to rewrite and to simplify and to evaluate. Feel free to pause this video at any point so you can write these down or try examples on your own. And then you can go ahead and try the next section of examples on the review. So we'll start with m to the negative 2/3. It's asking us to write that in radical form. So the first thing that I always notice is, in this particular example, my exponent is negative. So the first thing I do is I bring this expression down into the denominator. So I'd put that m to the negative 2/3 over 1, and I'm going to drop that expression down. So that's going to make this 1 over m to the 2/3, because when you move it down, the exponent's going to be positive, and then I'm going to rewrite this in radical form. So I'm going to drop down the 1, I'll bring down the m, that's my radicand here. I'm going to open up my root. My index here is always in the denominator of the fraction, so the index is going to be 3. And I'm going to raise that to the power of 2. So this is going to become 1 over the cubed root of m quantity squared. All right, let's move on. So 7x to the 3/5. So the exponent here is positive, so I don't have to do any movement. The first thing I'm going to do is I'm going to notice, okay, I've got a fractional exponent. I'm going to have to rewrite this in radical form. So I'll bring down my entire radicand of 7x, open up my root, put my index here of 5, and I'm going to be raising this all to the 3rd power. So this is one way of writing it. This is a perfectly acceptable solution. There are other people that like to put the 3 on the inside of the radical. That's fine too. But just make sure that if you write it that way, you would want to make sure that you're putting the 5th root of 7x as a quantity raised to the power of 3. Because if you don't put the parentheses here and you just put the 3 right there, that's just telling you that the x is going to be cubed, but the whole thing of 7x is cubed. All right, so next example is asking us to write kind of in the opposite way. So we want to take the cubed root of x and we want to write that as a fractional exponent. So I'm going to take my radicand, which is 1. My exponent here is technically a 1. Even though we don't have that written there, we can think about that x as having a power of 1. So my exponent is 1 and my my index is 3. So this is x to the 1/3 power. And then finally, number 4, same idea. This is actually kind of the opposite of what we were talking about with number 2. I'm kind of going back the opposite direction to get something that looks like what we started with. So my radicand here is 3x, and my power is 4. But when I raise this to the power, I want to make sure that I'm putting it in a set of parentheses to indicate that this entire thing is the radicand. So that's to the power of 4 over my index of 5. So my answer here would be 3x quantity to the power of 4/5. All right, I'm going to move to the next section, which is asking us to evaluate. So the next one that I want to work on is 81 to the 3/4 power. So I want to evaluate this without a calculator. So first thing I'm going to do is I'm noticing I've got a fractional exponent. I'm going to rewrite it in radical form. So in radical form, my radicand is 81. Open up my root here. My index is 4. And I'm going to raise this entire thing to the quantity of, to the power of 3. So my order of operations says I always want to work on the inside of the set of parentheses first. So that's asking me here, what number raised to the power of 4 gives me an 81? And I'd given you guys that chart to help you kind of figure that out. So if I evaluate the 4th root of 81, that's 3, because 3 raised to the 4th power gives me 81. I'm going to drop down that exponent of 3. So this is going to tell me that I want to evaluate 3 to the 3rd, which is 27. All right, next example is a little bit different. This time it's asking us to evaluate 25 to the 6 over 4. So again, I'm noticing I've got a fractional exponent, but here I can actually simplify this fraction. 6 over 4 can be simplified to 3 over 2. So that's my first step I'm going to take here. That one's a little bit different because 3 over 4 was already in simplest form. We didn't have to do any work here. but I'm going to rewrite this as 3 over 2 rather than keeping it as 6 over 4. So when I have 25 to the 3/2 power, my process is going to be pretty similar to number 5. I'm going to rewrite this. So bring down my radicand of 25, open up my root. My index here is 2. You can put that there, but you don't have to, because remember, a square root is just an index of 2. You don't have to put that there. And I'm going to raise that all to the power of 3. So again, I'm going to evaluate on the inside here. So the square root of 25 is just 5. And that's asking me to take 5 and to raise to the power of 3. And 5 raised to the power of 3 is 125. All right, my next one, and these ones kind of get a little bit tricky with number 7 and 8, so just be careful with these. So 7 is asking us to take -8 to the 2/3 and evaluate that. So just be careful, because I know it's really tempting to want to put that negative in the denominator, but remember that the negatives only go in the denominator when the exponent is negative, but our exponent is positive. So I'm going to just take the same steps I did in numbers 5 and 6. I'm going to rewrite this as a radical. So take my radicand of -8, open up my root. Here's my index of 3, and I'm going to raise that quantity to the power of 2. And in class, we had talked about what happens when there's a negative radicand. When you take that cubed root, remember that your answer has to be negative. So I'm going to evaluate here. This is asking me what number raised to the 3rd power gives me -8. Well, that would be a -2. So this becomes a -2. Drop down my power of 2, and -2 squared gives me a +4. All right. And then my last problem in my evaluating section is asking me to do 27 raised to the -4/3 power. So here, since our exponent is negative, this is going to be where I want to do movement first. So I'm going to put this over 1. I'm going to drop down this entire term down into the denominator. So 1 stays up in the numerator. This is going to become 27 raised to the +4/3. And then this ends up being pretty much like example 1 on the top when we talked about rewriting this in radical form. The only difference is that my radicand is just a number. So I'm going to do my work over here. So it's going to be 1 is still in the numerator. My radicand is 27. I'm going to open up my root here. My index is 3, and I'm going to raise it to the 4th power. So then it's asking me to do this on the inside here first. So the cubed root of 27, that's asking me what number raised to the 3rd power gives me 27. That would be 3. So I'm going to make this into 1 over 3 to the 4th. And then I can just go ahead and evaluate 3 to the 4th, which would be 81. So this becomes 1 over 81. All right, so just a quick reminder on evaluating. So we're going to move on to some simplifying. So we'll kind of go back to our properties of exponents on the next ones. So number 9, change the colors here, is asking us to do x squared times x to the 4th times x to the 5/2 raised to the power of 2. So I'm going to do things kind of in steps here. So I'm noticing that over here, these are already whole number exponents. I'm going to leave those alone for right now. There's a lot of different ways that you can go about doing these problems, but I'll kind of break it down into how I would approach these. So I'm just going to bring down the x squared times x to the 4th. And I'm going to work over here because I see that there's something to simplify here. So this is my power to a power exponent property here. So that's going to tell me I want to multiply those two. So I'm going to bring over the x to the 5/2, and I'm going to be multiplying that by 2 over 1. And I'm going to make that into a 2 over 1 just so that my work stays a little bit neater up here. So I'll bring down the x squared, bring down the x to the 4th, and I'm going to simplify here. So fraction multiplication tells me to multiply my numerator, so it's going to become 10. Multiply by denominators, that's going to become 2. And then this is all going to become x squared times x to the 4th times x to the 5th, because when you divide 10 by 2, that gives you a 5. And then my exponent property here says if all of my bases are x's, I can add my exponents together. So this is x squared plus 4 plus 5 So that's going to give me a final answer of x to the 11th power. All right, let's look at number 10. So this is x cubed y to the 1/2 times x to the 1/3 y to the negative 1/2. So don't let the parentheses here confuse you. This is basically the same thing as number 9, except to indicate that we're multiplying, we have parentheses here. But you actually, if those are confusing to you, you don't need them. That's really the same thing as saying x cubed times y to the 1/2 times x to the 1/3 times y to the 1/2. And then I'm going to look for my like terms. So I've got some like terms with bases of x. I'm going to write those together. So x to the 3rd times x to the 1/3. And then I've got like bases of y over here. So I'll rewrite that as y to the 1/2 times y to the negative 1/2. And then my like bases, use the rule that we did over here. Like bases, add the exponents. So I'm going to rewrite this as x to the, I'm going to put this as a 3 over 1 plus 1 over 3. I'm going to multiply that by, take my y terms, combine those. So y to the 1/2 plus negative 1/2. Over here with my x's, I'm going to need a common denominator, so I'll multiply the first fraction by 3 in the top and the bottom. So that gives me x to the 9/3 plus 1/3. And over here, when I add 1/2 plus negative 1/2, that gives me a 0. And there's that special property that we talked about, that anything to the 0 power is actually just a 1. So if I clean this x up a little bit, x to the 9/3 plus 1/3 gives me 10/3. And this is really just multiplied by 1, because y to the 0 is just 1. So, well, anything times 1 is just itself. So x to the 10/3 times 1 is just x to the 10/3. All right, so that takes care of our products, what happens when we have division. So 11 gives us y to the 2/5 times 2/7 times y to the 5/7 all over y to the 3rd raised to the 4th power. So definitely have a couple things going on here. I'm going to work in my numerator first. So same base of y, I can add my exponents together. So that's going to give me a y to the 2/7 plus 5/7 divided by, and here I've got a power to a power, so I want to multiply these. Be careful, I know some people want to add them together, but this is going to become y to the 12th. And then I'm going to clean up that numerator. So y to the 2/7 plus 5/7 actually gives me y to the 7/7 over y to the 12th. Well, 7 over 7 is really just the same thing as 1. So this becomes a y to the 1st over y to the 12th. And then my exponent rules tell me that I can really take these, if they're the same base, I can subtract the exponents. So y to the 1 minus 12 gives me a y to the negative 11. But if I were to take that and decide where it needs to go, since it's a negative exponent, it's got to go in the bottom. So this is going to become 1 over y to the 11th. Or if you want to think about it this way, what that's really telling me is I have 1 y in the numerator and I've got 12 y's in the denominator. 4, 5, 6, 7, 9, 10, 11, 12. So if I were to take the y's and cancel out the common y in the top and the bottom, I'm left with just a 1 in the numerator and I'm left with 11 y's in the denominator. So that's why that becomes 1 over y to the 11th. All right, let's do one more with division. So 12 is giving me something that looks a little bit different. So 32 over 243, all raised to the negative 1/5 power. So this is a little bit different because now I actually have a fraction all raised to the 1/5 power. I need to almost distribute that negative 1/5 into both the top and the bottom of the fraction. So in the top, it becomes 32 to the negative 1/5. In the denominator, it becomes 243 to the negative 1/5. And since both of these exponents are negative, I'm going to switch their spots. So the terms are going to be switched really. So the 243 is going to come up with a positive 1/5 exponent. The 32 is going to go down with a positive 1/5 exponent. And then I'm going to rewrite these to evaluate. So that's going to give me the 5th root of 243 in the numerator, the 5th root of 32 in the denominator, and that's basically asking me to evaluate, okay, what number can I raise to the 5th? That gives me a 243. That's going to be 3. Over what number raised to the 5th power is going to give me a 32, which is going to be 2. So that is actually going to simplify to 3 over 2. All right, let's look at a couple of more examples. So we'll look at 13 and 14. So 13 is asking us to simplify 27 times x to the 6 times y to the negative 9th, all raised to the 1/3 power. So I've really got a power to a power going on here, but it's more than one term. So this 1/3 needs to be on everything in this set of parentheses. Not only the x and the y, but also the 27. So when I write that out, that's going to give me 27 to the 1/3 times x to the 6 over 1. I'm going to write that as a fraction because I'm multiplying it by a fraction of 1/3. And y to the negative 9 over 1 times 1/3. So I'm just going to drop that down for a second. So 27 to the 1/3 power. I'm going to multiply out my exponents here. That's going to give me x to the 6 over 3. Multiply my exponents here. That's going to give me negative 9 over 3. Drop that 27 to the 1/3 down. Simplify the exponents here. X to the 6 over 3 gives me 2. Y to the negative 9 over 3 gives me negative 3. And then I'm going to tackle this piece here. I've got a number raised to a fractional exponent. I'm going to rewrite this in radical form. So this is telling me that it's going to be the cubed root of 27 times x squared times y to the negative 3rd. And 27, the cubed root of 27 is asking me what number do I have to raise to the 3rd power to get a 27. That's a 3. So this becomes 3x squared y to the negative 3. And then the last piece that I have to do here is this negative exponent. It's got to go down. So if I put this over a 1 and bring that term down, this is going to be completely simplified to 3x squared over y cubed. All right, and our last example, a little bit different. So we're asked to simplify 625, a to the 12th, b to the 8th, all underneath the square root. So I'm going to kind of split these up into their own roots. So this is going to give me square root of 625 times the square root of a to the 12th times the square root of b to the 8th. And the reason that I'm going to split this up is because I'm going to evaluate these separately. The square root of 625, I'm just going to drop down for a second. I'm going to work with my variables first. And since my variables are underneath a root, I'm actually going to rewrite these in fractional exponent form. So I'm kind of going the other way. So this is actually telling me I have an a to the 12th raised to the 1/2 power times b to the 8th raised to the 1/2 power. Because remember that the square root is equivalent to a 1/2 power. So this is going to tell me I'm going to drop down the square root of 625. If I multiply these out, that's really a 12 over 1. So 12 over 1 times 1 over 2 gives me 12 over 2. Over here, that's really an 8 over 1. So 8 over 1 times 1 over 2 gives me an 8 over 2. And then I'm going to, again, continue to drop down that 625. I'll simplify here. A to the 12 over 2 is a to the 6. B to the 8 over 2 is b to the 4th. And then the square root of 625 is actually just 25. So in simplest form, 25, a to the 6, b to the 4th. All right, so it's your turn to try some practice problems. Try the next section of problems on your review and let us know if you have questions.